At Danfoss, we know water.
Hi, my name is Klaus Lücking and I'm the Global Product Manager for the VLT AQUA Drive. With this short video, I will provide an introduction to the various flexible Cascade controller solutions available with the VLT AQUA Drive. I will also demonstrate how easy it is to configure a master follower application using the Smart Start setup wizard. With its unique features, the new generation VLT AQUA Drive is the perfect match for water, wastewater and irrigation applications. The VLT AQUA Drive is based on a combination of know-how, many years of experience, proven quality and global first-class service, together with the ability to control all typical motor types. The final elements of the foundations are the three pillars: energy savings, installation savings and water dedication. The advanced software of the VLT AQUA Drive contains functionalities for all operating conditions of pumps and other machines in water and wastewater applications. For commissioning, for startup, for operation and for stopping. The functions help protect the entire system in many ways. For example, by avoiding water hammer, reducing maintenance and by maximizing energy savings. The software of the VLT AQUA Drive is developed with a sharp focus on user-friendliness. A typical example of this is the setup wizard Smart Start. Smart Start automatically initiates at first power up or after the drive has been initialized. To initiate Smart Start manually, entry is via the quick menu. The Smart Start wizard guides the user through the entire configuration process. It starts with the language, motor parameters and other basic settings. After this, the user can choose between the following four applications: single pump or motor, motor alternation, basic cascade and master follower. At the final step, the user is asked whether he wants to configure one of the most common water and pump features or wants to quit the wizard. He can also open the submenu Water and Pumps via the quick menu. The submenu supports the features special ramps, sleep mode, deragging, dry run, end of curve detection, flow compensation, pipe fill, control performance and minimum speed monitor. In applications with varying load, it can be very advantageous to share the load. This is known as Cascade Control. The most important benefits of Cascade Control are improving the overall control performance of the system, adding redundancy and, very important, energy savings. This example shows that high energy savings can be achieved by applying speed control to a centrifugal pump or blower. The energy savings are a direct result of applying the so-called affinity laws. These laws state that the energy consumption can be approximately halved if the speed is reduced by just 20%, for example from 50 Hz to 40 Hz. If the load is shared between a variable speed pump and fixed speed pumps, about 5% additional savings can be obtained. And by controlling the speed of all pumps in a master follower configuration, in the same application, the reduction in energy consumption is more than 57%. Danfoss offers very flexible Cascade Control solutions. The Cascade controller of the VLT AQUA Drive supports the applications basic cascade control, mixed pump control, and master follower. An application with a basic cascade controller consists of a variable speed pump which is connected to a drive and one or more fixed speed pumps. These pumps run directly online or are connected to a soft starter. The contactors for the fixed speed pumps are operated by the relays of the drive or via a cascade controller option. Typical applications are booster sets. For master follower control, each pump is speed controlled, meaning each pump is connected to a drive. Each follower receives its reference as a pulse signal from the master drive. The followers are started by means of relays in the master. In this application, all pumps run at the same speed. Mixed pump systems are a combination of variable and fixed speed pumps. The configuration also supports pumps of different sizes. Master follower and mixed pump systems require installation of a cascade controller option. As we can see, the number of controllable pumps depends on the hardware configuration. Up to 8 pumps can be controlled. The options additionally enable alternation of the lead pump by using 2 relays for the fixed speed pumps. This reduces the effort and costs for wiring. I will now explain the wiring required for a typical master follower configuration. The I/Os in this configuration will also be used for the programming example. In a master follower configuration, each pump is speed controlled and connected to a drive. The start signal for the Cascade application is an external signal connected to digital input 18 of the master drive. The master drive runs in a closed loop process and therefore requires a feedback signal. This feedback signal is provided by a pressure transmitter connected to analog input 54. The master drive starts the follower drives by means of its relays. In this case, connect master drive relays R0 and R1 to digital input 18 of each follower drive. Finally, each follower drive requires a speed reference. Program digital output 27 of the master drive accordingly. Then connect it to digital input 29 of each follower drive. For this purpose, configure digital input 29 of each follower as a pulse input. In the following actual programming, the application consists of 2 drives, but the wiring is similar. First, I will configure the master. I will enter the Smart Start by using the entry in the quick menu. The first thing is we are asked for the language and I will confirm English. The choice International pre-configures several settings like the motor power unit. The motor type we are using is asynchronous motor. As protection of the motor against overheating, we are using the inbuilt ETR feature of the drive. There is no external fan for extra cooling of the motor. We have now to enter the motor data according to the nameplate. The motor power is 0.46 kilowatt. The motor voltage 400 volt. The motor frequency is 50 Hz and the motor current 1 ampere. As motor speed unit, we are selecting Hertz. The motor nominal speed is 2,900 RPM. We are not using a sine wave filter at the output of our drive. We will now start the automatic motor adaptation AMA. And confirm this by pressing hand on. The AMA is now completed. As ramp times, we will use 8 seconds for the ramp up time, and 15 seconds for the ramp down time. In the application section of the Smart Start, I will select Master Follower. This drive is the master drive of the application. Just by choosing Master, the drive will set some parameters like the ones for the I/O configuration automatically. The motor speed limits are 30 Hz as the motor speed low limit and 50 Hz as the motor speed high limit. For the feedback of the master drive, which is running in closed loop, we select the analog input 54. This screen asks us to check the dip switch of the drive, which allows us to switch between voltage input and current input of the analog input for the feedback. As a reference and feedback unit, we are choosing bar. The range of our feedback transducer is 0 to 4 bar. We will use an internal set point, which means a fixed set point of 1 bar. We have 2 drives in our application. We will now configure the relays. In our case, it is only 1 relay for starting the follower drive. We want the master to stage and destage with a delay of 10 seconds. The follower will be destaged at a speed of 42 Hz. And the last running pump will be destaged at a speed of 31 Hz, which is just above the minimum speed. We want that the Cascade controller wakes up again at a deviation of 0.2 bar from the set point, which is 5% from the maximum reference value. We have now finished the programming of the master. By pressing OK, we jump directly to the quick menu Water and Pumps. We want to use this menu for configuring one additional feature. In the application, we have a check valve. In order to avoid water hammering, this has to be closed slowly. We'll use the check valve ramp for doing this. The check valve ramp is one of the special ramps. We adjust the check valve ramp time to 10 seconds. And the check valve ramp end speed, which is the speed when we expect the valve to be closed, to 25 Hz. Now I will program the follower. I will enter the Smart Start again by the entry in the quick menu. As you will see, most of the settings, at least of the basic settings, are exactly the same as for the master drive. We have to enter again the motor data, and because they are the same for the master and the follower, we are using, of course, the same settings. Again, Hertz as motor speed unit, and of course 2900 RPM as the motor nominal speed. We are using the same ramp up time and the same ramp down time. In the application section, I will select again master follower, but now the follower. Just by having chosen follower, most settings have already been done automatically by using the right adjustments for the IOs, like the pulse input for the speed reference. What we still have to do is to enter the motor speed low limit, and the motor speed high limit, which are the same as for the master drive. Finally, we program the check valve ramp also for the follower drive with the same settings as for the master drive. "10 seconds for the closing time, and 25 Hertz for the check valve ramp end speed. We have seen how the user-friendly Smart Start Setup Wizard helps to program the application. It just took a few minutes for a system consisting of 2 pumps. I would like to conclude with a short summary. The demonstration has shown that programming the master follower application is very easy due to the Smart Start integration. The Smart Start Wizard assumes that the wiring is performed in a standard manner. Nonetheless, changes to the I/O configuration can be performed via the main menu. The operation and the staging-destaging principle of the master follower application are very smooth. This improves the overall control performance and helps to avoid water hammers. It also reduces non-revenue water flow. In the event of a pump failure, or if a pump is disabled for maintenance, the Cascade controller will try to compensate for the missing pump. In a master follower application, all pumps run at the same speed. Sharing the load between the pumps in the system ensures a highly efficient operation. Load sharing also saves energy by continuously monitoring the energy consumption and adapting the staging speeds if required. Thank you for joining me today. We invite you to contact your local Danfoss supplier or to visit danfoss.com/AQUA Drive for more information.
No matter where in the world or what your water project, new generation VLT AQUA Drives are there for you. At Danfoss, we know water.